Hello? Okay. Do we have it now? Did we figure it out? So everybody can hear me. Just give me your yes if you can. All right. Hooray. This way you don't have to just look at silent slides. You're all here early. I'm so happy to hear that. I see that you're just eager to learn and you're just good students. I'm very happy to see that. It's very rewarding. I really enjoyed everything you did during the week. There was a lot of work in the discussion forums. You guys understood the material very well and you take your education very seriously. I am proud of all of you. So I think that you will all do very well in this class. That is for sure. And I think you're going to do even farther than the class and learn more and be ready already to be systems programmers after you're done with this class. You'll be wizards and experts. Okay, so just a little note on, we did go through our week 1. How did you like it? How did you like week 1 so far? Did you like it? Did you learn something? Did you already know it? Or is it new to you? Thank you for your kind words, too. I love teaching and I love sharing my information. Yes, new information. For most people who use computers, they don't know this. They just know how to use their computer, but as to what works or what's working in the background, they usually don't know. So it is new information and also the detailed information, but everybody should know it. No matter what field you go into, you should know it. And that will just make you better than everybody else who's there. Because again, most people don't know it. So if you do know it, and if you're in the workplace, you will look highly regarded as really understanding and knowing the material. So now that you're in school, take the time to learn as much as you can. We only could do so much in the office hours and live lecture, but the more you do, you know, when you're not in class, the better you will be and the more knowledge you will have. So just keep reading and understanding what you're reading and ask questions if you don't. And also explore. There's a lot of information you can add to what you read in the textbook, and that's in the library and on the internet. There's lots of videos, especially in YouTube, on all this material. So you can keep looking for more information, and sometimes even if it's the same information, when you hear it again, you know, 1 or 2 or 3 different times, it then just registers better in your memory. So it's a good way then to get the information, you know, so it's like second nature to you. It's not something you have to think about, not something you have to look up. You will already know it. So the more you look at it, the more you explore it, the more you look in the library, the more you look on the internet and YouTube for videos or tutorials, the better you'll be. Okay, so it's a great first week, in my opinion. All of you did well. Oh, just a couple notes. Now, if you missed, for right now, the office hours are optional, okay? But I will be discussing material, and I will also give you some optional items for you to look at that will help you then for later weeks in the class. So it's a good thing to come to the office hours, but you don't get a grade for it or points, but it's good that you come, and I see that many of you are here. But then some of you are busy, and when it came to the live lecture, now the live lecture on Wednesdays are required. You have to come to that because you get points for that. And if you don't come, you don't get points. However, I understand that a lot of you may be busy or that time doesn't work for you. So what you can do, in case you can't make the live lecture, you can give me a summary of the presentation. These will always be recorded, so you can give me a summary of the presentation, email that to me, and then I can give you points for the virtual class. So that is an option, but of course it's always best to be here when it's live, because if you have questions, I'm right here right now to answer them for you. But again, the recording is there. I will also record the office hours. So the recordings are always there for you to view again, or maybe there's something you didn't understand, you want to see it again. They are there. And I will also give you the slides. So for this office, last week I didn't have slides for office hours. This week I will. I will give you the slides and there will be the recording. Same thing for the virtual class. But again, virtual class is required for points. So depending on if you can make it, try to make it. That's the best way to do it. And also before the live lecture, try to read all the material and look at the videos so that if you have questions, or maybe you didn't understand something and I talk about it again, it helps you understand it better. Or if you have questions, again, I'm there. And also look at the assignments. Look at them in the beginning of the week. Even now, if you looked at them and had questions. I did have somebody, I did not get into discussion question yet, but I was there yesterday and I saw already a question. So when you give me a question, I will give you an answer. I will also give you maybe another link. I will also maybe give you a video. So yeah, ask me questions, because then I'll give you extra information so that I want to make sure you really learn it. Because this can be confusing and this is very detailed. And I know you have your midterm and final exams where you have to really understand this material. So it's a good practice. The more you look at material, the better you'll get it. Okay, so let's go on to, again, this is a repeat. Again, we had our first week where we got to know each other. Lovely group. I really enjoyed reading your introductions, and I really am proud to be your instructor, and I really am proud of all of you that you're going to school and that you really are interested and want to learn this material. And this is just some structure I'm going to put to the class just so everybody knows what is what, and it's easier than when you are doing the class. For example, every Monday I'm going to be here for office hours. It is optional, but I'm going to go over some good material because this way, I'm just going to be there for you to help you out and give you more information, only because I like to do that. Okay, Wednesdays, you have your live lecture. Also, I'm going to put a discussion question. Now, these discussion questions are not graded, but it's a good way for us to work together in the discussion forum because you can put your answers and you can put your questions. So I will put something just to get you started so that you know what to look for because you have a lot of material. So I'm going to try to highlight the more important material and get you thinking and get you going. And anything you put down, you write for the discussion question you can use to study for the exams. It's kind of like taking notes. And it's always a good idea to have notes when you are studying for any exam. So Monday's the office hour. Wednesdays we have the discussion question and the class. And then Saturday is the last day of the week. Every week runs from Sunday to Saturday. So Saturday is the last day to get all your assignments in. Also reply to your classmates. The more the better. And also in case you missed the live lecture, then get the summary to me by Saturday. Some of you were not aware of this, so I will extend it for week 1. I think there's one more person who needs to give this to me. But for weeks going on in the future, every Saturday is the last day. Every Saturday, everything is due. So then we can start fresh on Sunday for the next week. And again, just to repeat, the exams are week 8. The midterm is week 8. The final is week 14. So any questions on this? so we're kind of clear, then we can all work together and know, you can expect and know what to do and when to do it. Are we any questions? Oops. Okay, we have a question. Go ahead. I don't know, I have a hand raised. So if you raised your hand by accident, that's okay. But if you raised your hand because you have a question, okay. I know, sometimes I click on the wrong thing too. All right, so we're all good. Okay, again, don't hesitate if you ever have questions. That's what I'm here for, is to help you, to learn it. So make me work. I love to work. I like to feel needed. Okay, you do have a question. Okay, go ahead. You could type it or you could talk. It's up to you. For sure. Okay, yeah, but I think you were not, yeah, if you were not in the, wait, I got my list. Yeah, I get a list every time of all the people in the live class, and then I could know. Yes, you could give it to me today. But just for future weeks, because we didn't know yet, so that's fine. We're just starting to practice and starting to understand, or I'm starting to put some order to everything. So yes, you can still, everybody who still needs to give me a summary, please do. And then from the future weeks, it's going to be due Saturday. For week 1, you can turn it in as soon as you get done. Okay, here's a summary of week 1. You're welcome. Well, yeah, it'll be both, yeah, multiple choice, true, false. However, there will be some programming code. I'm going to be talking about some of that now. So yes, you're going to have to know definitions. So that's why every week, or you can as well, but every week there's topics. So like, for example, chapter 1, here are the key topics. Yes, I will give you the slides, and then I will give you, even when the exam comes closer, I will give you a list of information to make sure you know it. So it will be definitions, it will just be understanding, you know, different programming code. You're going to be covering the entire book. So the entire textbook will be on the final exam. And midterm will be up to the point we're at midterm. So you will have to know everything. You have to know all of it, but I know you can do it. I have faith in you. Again, I will give you a midterm review sheet, a final review sheet that will help you study, and I will also be giving you every week these lists of key topics. So what you would want to do is make, write down, maybe a paragraph that answers each of this, or put down just some key points concerning this. So every week, for example, this is chapter 1, then I have chapter 2. So you can go over each topic and then make sure you understand it. And also another helpful tip is to do the exercises. I know right now we just have some exercises you have to do and turn in to me for a grade that I will grade and give you points. But it's always a good idea to know all those exercises. If you can go through the book and at the end of each chapter you can answer those exercise questions, then you will be fine for their exams. So that's extra practice for you. And if you want to do something, one of those exercises, you have questions, put it in the discussion forum. We all can work on it together. So that is a good way. Know the topics and complete all the exercises at the end of the chapter, and you will have no problem taking those exams. So I hope that helps. Okay, so again, here's week 1. We kind of just went over operating systems. You all did a lovely job in the discussion. And that's what the discussion questions will be. They'll kind of give you questions and have you look at material that for sure will be on the exam. So that's why it's a good idea to answer that discussion question. Even though you don't get any points, it gives you good practice, and you can even put your answer like in another document and use it to study for the final exam. Because when we get to the exams, you're going to have many chapters. So start taking notes now and having your information now, so then it's just easier when the exam comes. So we went over the introduction of operating systems in week 1 and the system structures. Kind of was a little complicated, the system structures, but if you think about it, what it really is just the applications that end users use. We talked about utilities. We talked about what operating systems have for you. And that is good information for the system structures. Okay, so if you go to the topics again, so here are the key topics for Chapter 1. Know about what operating systems do, the organization, architecture, structure, operations, and the various managements. Now these managements we're going to go through one more time. We're going to look at process management just like we are right now in week 2. We're looking at it in more detail. It was introduced in Chapter 1, but a lot of these topics, we're going to revisit them again in a little more detail as the course continues. Memory management, we'll have a whole week on memory management, another week. We'll have another week on storage management. We'll have another week on protection and security. So just kind of know basically what it is. You're being introduced, and then later we're going to look at it in more detail. And then in Chapter 2, System Services, we'll be looking at some of this and even programming some of this. So these are some things that the operating system does for you. Talks about how to do it, how it gets processed, and then the structure, debugging, in case there's errors. We always have errors. We'll be talking about those. How to make sure that the operating system doesn't crash. The system boot, very important. What happens when you turn on your computer? So something very important for you to understand. Understand the process. Even when you turn on your own computer, you might see some information flash on the screen. This is what happens when it goes through the system boot. So it's just the process the operating system goes through so that your computer does start up and then it's ready for you to give it instructions. So that was involving the firmware, BIOS. It goes through a post-test. So again, good information. Take your notes for all these topics. Okay, any questions on week 1? Any questions with Chapter 1 or Chapter 2? Again, we didn't look at the exercises, but a good idea is now look at the exercises in Chapter 1 and Chapter 2 and see if you could do them. Okay, now week 2, we're looking at processes. That was one of those areas we were introduced, and that was process management. Yes, the operating system has to keep track of the programs that are running. Because when you say, I want to run this program, the operating system has to do it. And also, what if there's more than one program running? It has to then coordinate or manage all these programs. Don't forget, the operating system itself has running programs. When you start up your computer, you can see all the programs that are running. All those programs that are running have to be managed by the operating system, so it doesn't get confused. So it doesn't by accident, you want something to go on the screen, and by mistake it sends it to the printer. It can't do those kind of things. So there's a lot of strategies that are used. And also, as you go through week 2 and the chapter 3 and chapter 4, start looking at the programming code. The programming code gives you the strategies and logic that are used by the operating system, and also allows you to know how to write programs so you could do the same thing. Now, you all mentioned that you took Java. Does any of you know C, programming language of C or C++? Or do you just know Java? But you all know Java, yes? A little bit or very well? Java forever, okay. Yeah, it's a wonderful programming language because of the way it's compiled. Most programming languages are compiled and on the same machine. But Java allows to be compiled in 2 steps. The one step is on the machine for whatever is machine independent, and then is sent to the user's machine to continue or finish the compilation of the code on the user's machine, so it makes sure that it can work on that user's machine. And then the virtual machine. Yes, we will be using the virtual machine for this class as well. If you have one that you used for your Java class, then you probably will be using that same one. If not, there is one discussed in the textbook, and you could use that one. So we are not there yet where we're programming, but we are looking at programming code. So you can start looking at code. And do you think, if the code is written in programming language C, and you only know Java, do you think you still will be able to understand the logic of the program? What do you think? Yes, exactly. You will have the general idea. Pretty much, programming language have the same kind of structures and assignment statements and function calls. So you can pretty much understand the logic. You may be not too sure on the syntax, only because the syntax does differ a little bit, but you don't need that right now because you're not writing programs. Not in C at any rate, or C++. So if you know Java, you'll be able to, you won't have to write them. You can always practice. I always say, if you understand one programming language very well, it won't be too hard for you to learn another programming language, because all the basic structures of the programming code are there. You still have sequence statements. You still have decision statements like if, then, else. You still have repetition like while, do, or do until, or the for statement, for loop. Since you know all these statements and how they work logically, you can then just quickly learn the syntax for a programming language and be able to work. So the logic is the same no matter what programming language you use. For the most part, it's just the syntax that's a little different. But syntax probably is not as difficult to learn as it is the logic. So if you learned how to program using a programming language, then your skills for programming are already there. And that is easy to do in a different language than picking up the syntax. So you can always practice. You can very easily take one of your Java programs that you wrote in your Java class and be able then to see if you can write it in C++. It just may be different classes and different names for the classes, but they pretty much function the same. Especially when it's just lower level programs, pretty much everything runs the same. So if you have Visual Studio, you can always practice and see if you can do that. Java, on the other hand, is open source, and you can download it and program with it. But at any rate, the process is the same. Now, one thing when you're going to be programming for this course, what's very important is the logic. You have to understand the logic. That's what makes the difference. And that's why it's complicated, because there are a lot of issues when there's management involved. What to do, because you have a lot of data coming from many areas, from many users. You have users, or a user who maybe wants to do several different programs. And then each program needs stuff. For example, each program is going to have to maybe need to access data that's in the memory, or access a file that's on the hard drive. So each program has a lot of requests also. So the operating system has to manage it and has to know what to do in what order. So it's the scheduling that we will be looking at as well. That's going to be next week. We'll look very deeply into scheduling. But right now, we're going to be looking at what a process is, the strategies that are used to create a process, and how to create it in the different programming languages. Now, when you did do programming, I don't know, did you ever do flowcharts? Did you have to create flowcharts for your programs, or did you create pseudocode for your programs? No. Okay, this is something you may want to do. It's never a good idea just to jump in front of a screen and start typing out a program. You probably did it without even knowing that you did it, because you had to make sense out of what code you're going to write and when you're going to write this code. So you used just some simple classes. Okay, we will be using the simple classes as well, but you will have an extra level where you have to understand the process and logic of your code as well. Because that is what the operating system does. It has to do the scheduling, and it has to manage these processes, and it has to know how to do it when there's many requests. So that is something you will look at. I do have some practice exercises here that you can look at that'll help get you used to looking at this logic. But here's the definition of what a process is. So I think, do we all understand a process? Do we know that it's just a program or something that the computer has to do, and the operating system has to make sure that it gets to RAM and then gets passed to the processor? Is that a good, simple way to put it? Or do we have any questions on what a process is? Okay, so you're good on what a process is. It's just something that the computer has to execute. It's an instruction. Think of the process as an instruction or a series of instructions, and the operating system has to make sure the processor gets the correct instruction in the correct order. You can't do something before something else if it's not the correct order. So the operating system has to make sure that this is done in the correct order, in the correct time, and also all the information is given for the instruction. In case the instruction needs data, it has to be able to access it. And then we'll look even deeper when we look at memory management, because all this is in memory. So on top of it, not only it has to know what instruction needs to be processed when, it also needs what memory location is it located. So there's a lot of sophisticated jobs that an operating system has to do. And thank goodness we don't have to do it, that the computer does it for us. Otherwise, it definitely would be hard to program. Like in the old days, you actually had to specify what register was what information and take this information from this register, add it to that register, and put it to the ALU for processing. It was very tedious, but the operating systems now take care of that, as well as your compilers, and then when you execute. Okay, a thread. Now, why do they distinguish between a process and a thread? What they're doing is saying, okay, a process may be an entire program, and a thread will be just part of that program. So it's a way of making the units into manageable subunits. Now, all object-oriented programs like C++ and Java do have classes to deal with it. And hopefully you are familiar with the Java API reference library. Have you used the Java API reference library? Did anybody use it? Did you know about it? Do you know what the Java API reference library is? Okay. All object-oriented programming languages have libraries of code for you to use, or classes. That's what makes up the programming language. So the API reference library has all these classes for you described, all the information about it, so that you can use it. It's extra information. Probably in your Java class, you were just given code and you would use it to create your programs. Well, the API reference library has all possible code that you could use, all possible classes that you could use. And what's nice about it, when you take a class and you learn about a programming language, sometimes you only learn some of it. That's only because there's so much. So they can't cover everything in a class. I mean, in instruction, a session of a class. I mean, not a programming class, but a student class or a school class. There we go. So when you're in school and you're learning a programming language, you only can learn so much from the textbook. But the API reference library has everything. So it's always nice that when you use something, to go to the API reference library and see what more there is about it. There might be more detail. There might be more methods. There might be more ways you could use it that the textbook didn't show you. Because your textbook can only show you so much. And also, all these classes have what is known as hierarchies. I think you know, an object-oriented programming language, you have parents and you have children, or superclasses and subclasses. So the API reference library will show you all these hierarchies. And that's what you know then, where is this information coming from? Because some of it is you are inheriting information from superclasses or parent classes that you don't even know you're using, because you're in an integrated development environment such as Eclipse or NetBeans, and a lot of that stuff's already done for you, so you're not aware of it. What integrated development environment did you use for Java? Did you use Eclipse, NetBeans, BlueJ? Okay, so you use BlueJ. Very similar. It puts some information in for you. It helps you out. That's what an integrated or an IDE does. It helps you out with your programming. Some help you out more than others. There's something called PACE tools, computer-aided software engineering, that really help you out with you. Not only programming, they help you out with the design and logic of your program. So there's a lot of levels to a program. A lot of it is automatically done for you in your integrated development environment, but it's good for you to learn where all this is coming from. And all that information are in your API reference libraries. So in one of these slides, I do have the link for Java, so you could take a look at it. Again, anytime you go to any class, you're going to see all the methods. You're going to see the different methods. You're going to see the parameters, how to use a method. And you'll be surprised. There's methods in there maybe you didn't even know were there because your textbook just showed you one or two of them. So again, this is how to become a power programmer, by going to the source of where everything comes from. So we'll be looking at that, and later in the course you will have to do some programming, but you might as well start looking at the programming code now. So we're going to be looking at processes, we're going to be looking at threads, we're going to be looking at multi-threads. And most operating systems provide kernel support for threads. So you're going to figure out how does this all tie in together. So we will look at that. Here are the different topics in Chapter 3. It's about what a process is, scheduling processes. We're going to go into that more next week in more detail, but it's introduced to you here. Operations on processes. How do you get a process to start? How do you get a process to stop? So these are the kind of operations. When do you delete a process? You don't want a process to be sitting in memory if you're not using it any longer. So you have to delete it. Or when do you need memory for your process? You have to start it. And how processes communicate with each other. Again, you may have more than one process running or sub-processes running at the same time. That's just to make it efficient. You know, you might have one instruction at a time working. If you have one CPU, you have one instruction at a time that can be processed. However, you can have the rest of the instructions getting ready to be processed, because that processor works very quickly. So you want to bring information to it and close to it as much as possible, so as soon as it's done, you can pass it to the next set of information. So we're going to be looking at these strategies, how to know what to put where. And if one instruction is done, okay, what communication does it give that it needs the next instruction? So you have inter-process communications. And also, we're going to look at some communication in client-server systems. So this is more the hands-on and application parts of operating systems. This is actually looking at how they function, how operating systems actually work in the background. Not a matter of just knowing what utilities and operating systems have and be able to use them, such as disk cleanup or disk defragmentation. This is actually understanding how the instructions are processed and when. And then Chapter 4, we'll look at the multi-threading. Thread libraries, that's what I was mentioning about the libraries. Every programming language that deals with threads will have a library, and you will learn what classes you use and what are the different methods that are used to, again, create a thread, to run a thread, to stop a thread, to delete a thread, and all those type of operations. And also, there's issues that come up. What if there's two processes at the same time wanting a resource? They both can't have the resource, so what should be done? So there's a lot of traffic cop kind of programming strategies that we will learn. So do take a look at the logic here in the code. Do refresh your memory on programming. So here's the instructions you need to complete for week 2. You want to read the introduction, chapter 3, chapter 4, and then watch these videos. And again, if you have questions, bring them into the discussion forum. That way I can answer them right away, or your classmates can answer them. Or maybe your classmates had the same question, but they were shy to ask it. So then you could be the leader and then ask the questions and make sure everybody can understand the information. You'll be helping your class and helping yourself. And also, I will feel needed. I like to feel needed, and I like to work. So give me your questions. Okay, week 2. Again, the usual. Wednesday, we have the virtual class. If you can't make it, try to make it. That's the best. But I understand things are going on in your life. If you can't, then make sure you look at the recording and give me a summary by Saturday. Wednesday, you have your discussion question. Again, you don't have any points for this, but I do recommend you do this because it's like you starting to take notes to study for your final exam. Also, you're going to get information from your classmates that you maybe want to add to your notes for when you study then for the exams. The summary is only if you do not attend the virtual class. If you attend the virtual class, you do not have to do the summary. It's only those who do not attend it but view the recording. And this way I can give them points because how will I know if they looked at the recording if they don't give me a summary? So a summary is for me to know that you at least viewed the recording. But do know the recording is there for you to view as many times as you want. Even if you do the live session, maybe you want to hear it again. Maybe you didn't understand it, or maybe you read your book and finally it made more sense. So you can go back to the recording to hear it again. And then here you have some end of the chapter exercises. These are the part that's graded. You're welcome. These are the parts that's graded for week 2. And then there is a Dropbox. Hopefully you're familiar with Blackboard to find the Dropbox. Now you could either type in your answer or submit a document file. Either one. A document file is probably a good one because this way I can make notes on your answers and then I can give you back that file and you can look at it with my notes. So maybe you want to put a file in the Dropbox, and then I will grade it, and then I offer you my answer, my comments, and then give you your grade. And I will usually do grades on Sunday. So very important, get everything done by Saturday because I'm doing grades by Sunday so that you can get going then in the next week coming up. And these assignments are worth 15 points. And this is pretty much how it will be every week. You will usually have some exercises in the book, and then you will also maybe have some additional. I know one week you have to read an article, and you have to write something. Another week you're going to do a little programming code, and then submit it. So as we go, there may be more than one set of instructions, but whatever it is, you always have to complete it by Saturday. Here's the discussion question. Again, this allows you then to make you think about it, put down a summary for you to use so you can use it to study. Work with your classmates in case they don't understand something, then you can help them understand it. Or you understand something, you can help your classmates understand it. So it's a way to work together and you can put it in the discussion forum because it's not like you see each other every day. So it's not like you see each other and can talk about it. So this is the best way now, is to talk about it in a discussion forum. Think of it as having a meeting with your friends and your classmates, and you're all talking about the topic. So here's what we're going to talk about. What is a process? What resources does it require? What is the difference between a process and a thread? What are the responsibilities of an operating system in regards to process and thread management? So any questions on the question? One of the, I think there was a classmate already. There's in the general Q&A section, somebody asked a question, and I offered additional links and videos. So I will do this as well. Let me know if these extra links help. Okay, I have all, but one thing I will do, I will always have the questions in the office hour slides. I will write them out for you here, and you will have these slides, because I'm understanding that there's different versions of the book, or there's some issues with the book. But they're at the end of the chapter. At the end of every chapter, there's a section called exercises. So when you get into the bookshelf, on the left, you will see all the sections for that chapter. And then one of them, right after summary, there's a section called summary, and right after it, it's called exercises. That's where they will be. But I also will bring you a copy here. For example, here we go. Here's exercise 3.2. This is one of the questions. Describe the actions taken by a kernel to context switch between processes. Now, this might be new to you because maybe you didn't read the chapter yet, but I will give them to you here, and then you go ahead and explore it. And if you have any questions, then we can talk about it on Wednesday. This will give you some time to read and explore and come up with an answer. And then Wednesday, if you have questions, we can talk about it. And Saturday is when you have to give me the answer to be graded. There you go. It's page 167. Thank you. I will do that next time. I wasn't thinking to put page numbers. And then here's exercise 3.6. Again, page 167. Explain the circumstances under which the line of code marked printf line J in figure 3.32 will be reached. Here we go. Now you're going to start looking at some code. Hopefully you like programming. Hopefully you like programming code. Hopefully you understand it. Now, do you have to be a fantastic programmer to understand operating systems? No. That's only if you like it and it's part of your characteristic to be a good programmer. But if you have some understanding, sometimes people can understand it better if they look at the programming code. And then sometimes not. Sometimes they have to read about it to make sense out of it. So it all depends on what better way you learn. But understanding programming code is always a good thing, because no matter what you do with computers, no matter what kind of IT professional you are, understanding the logic of program code or scripts or settings is a good thing. So here's the code that they're talking about. This is the code that you have to analyze. Now this is written in C, but some similarities I can point out to you. I think right away you see some similarities if you know your Java. Here you have these include statements at the top, but those are similar to your packages, if you think about it. You see the main. I think you had a main when you were doing Java. Main is what typically all object-oriented programming languages have, that is something recognized as the starting point for execution. The PID is process ID, if you're not sure what process ID is. That T is like a template, if you want to think about it. So if you use classes and make a copy of classes so you could use it in your code, that's what that is. Fork is a child process, so you can start looking at these different methods. Again, I'm not going to give you the answer right now. I want you to look at it and understand it, and then if you have questions, we can talk about it on Wednesday. So I'm just giving you some of the information here a little bit. But again, you should be familiar with what if statements are. When something is equal to something, you should know what that means. If something is equal to something, that means it's a comparison, relational comparison. Okay, so that's what you're going to look at for that question. Yes, and thank you. 411 is on page 210. Thank you very much for the page numbers. And here it is. I will then include them from now on. I just found sometimes in a classroom people might have different versions of a book and they have different page numbers. So I did not have a habit to do that any longer. But I am assuming you're all going to have the same book, so we're all going to have same pages. Okay, so as described in section 4.7.2, Linux does not distinguish between processes and threads. That means Windows does. So we did talk about there was a difference between a process and a thread. Now you know, Linux doesn't distinguish, but Windows does. So instead, Linux treats both in the same way, allowing a task to be more akin to a process or a thread, depending on the set of flags. Oh, you just need the last sentence. If you look at this last sentence, contrast these two approaches for modeling processes and threads within the kernel. So just talk about the differences between how Windows handles processes and threads and how Linux handles processes and threads. The main idea here is Windows makes a distinction between subprocesses and threads. Linux does not. So, for example, Linux threads refers to them as tasks rather than threads. So this is something you would put as part of your answer. Thread creation is done through clone, which is a system call. Clone allows a child task to share the address space of the parent task. Now that's when you, if you have your understanding of object-oriented programming. When you have classes and you make a copy of your class, when you make a copy of a class so you could use it, it makes a new set of memory for you. Or it uses a new set of memory. So here in Linux, it doesn't set up a new set of memory for you. It uses the same one that the parent is in. So that's a good thing in that it reserves, it doesn't take up so much memory, but on the bad side of that is it might get confused between which one is the child, which one is the parent. So there's some extra programming that needs to be done so it doesn't confuse the two. When they have actually two separate memory spaces, then there's no chance to confuse the two. Because they'll know parent is in this memory space, child is in this memory space. There's no confusion. In Linux, they use the same space. So you need some extra level of monitoring and managing to know then when it's using that same space, when the information is the parent's information and when is it the child's information. So a lot of different strategies. And this is the section you're supposed to read. So this refers to all the information on Linux. This is in your textbook. It's the 4.7.2 Linux. And again, I will give you page numbers next session. Always. From now on, I will always give you page numbers. And there it is. So I'll let you read it. Again, make sure you read this. And if you have questions, bring them to the virtual class. Now these are Windows threads. So this describes the differences. This is how Windows threads work. Again, they make a separate space. Okay, page 206. Thank you. So that section 4.7.2 on Linux is on page 206. So these are Windows threads, implements one-to-one mapping, kernel level. Again, you did explore what a kernel was last week. Now you're going to kind of look at how a kernel actually works. These are part of the thread class. You have an ID. You have a register for the state of the processor. Is the processor ready to take something? Is the processor busy? Or is the processor done? Separate user and kernel stacks. Again, you have a lot of information associated with an instruction. So you have to keep all this information. For example, if it's an instruction that's adding 2 numbers, well, you need those 2 numbers. Also, you need space for where the answer will go. So that's all this information that needs to be kept together, as well as you need the next instruction. So the stack can have one in the first instruction, then the next instruction, then the next instruction, so that it can continue processing. Again, we want to organize everything for the processor because the processor works so fast. So the more organized we are, the better we know what's coming next for the set of instructions, and the faster we can pass it to the processor. We don't have to go look for it. We're going to have it all there together in a stack. So something for you to look at. So you can look at E thread, K threads. K thread, kernel thread. K is for kernel. Here we go. Here's some example. This is for Windows XP threads data structures. So that's how the information is kept. And that kind of looks like a class diagram, doesn't it? So very similar to a class diagram in the sense that this is the information and this is how it is kept. So again, something for you to look at. Here's some code. Here is some code to create a separate process using the Windows API. Remember, this is for Windows. Linux, on the other hand, uses the clone. So again, those are 2 differences. And we have different level models. How are they separated? So there's the 2-level model, many-to-one model, one-to-one model. And here's some optional practice for you. So again, go view this. We will talk more about these models. You will look at already the differences between Windows and Linux. And we'll just talk about more of the strategies in detail on Wednesday. But for right now, again, it is just the office hours. So here's some optional practice to get you used to understanding the logic behind the code. So here we go. Here's a practice. What output will be at line A? So something for you to explore. Again, if you have questions, bring it into the discussion forum. You can start now asking questions. Or you can bring it to you on Wednesday when we have a live session. But make sure you understand this all by the end of the week. This is important material to understand. Another optional practice. How many processes are created? So hopefully, if you're not too, maybe a little rusty on your programming code, this will give you a way to get back into it. 313, again, there's a series of these questions, starting with 313, and then it's in chapter 4, and then it's again in chapter 6. So this would be a good practice for you if it's something you want to look at, because you'll see it's the same thing that's changed for chapter 4 and then changed again for chapter 6. So good information for you to look at, because it already is. Here's the optional practice for Chapter 4. So you have the Chapter 3 version, you have the Chapter 4 version. So do take a look at that. Again, just for more practice. And here's the links for the Java, this was the API library, not APA. But here's the link for it. Here's the link, another little discussion on Java threads, some additional resources for you. And I mentioned the hierarchies. Again, hierarchies are very crucial in object-oriented program. That's how it's built. Because you have parents, you have children, and you have inheritance, as one of the classmates you mentioned. So this is where the thread comes from. It comes from its parent-to-parent classes. It implements java.lang runnable. That's for the interface. And then it extends or inherits from java.lang.object. So I'll refresh your memory on what all this means. Go to the API reference library to see all the information on at least these classes to know what you're working with. Here's just a little model as to how requests are handled. So you have incoming request, server program. Each request is handled by a thread. And then one thread to update the graphics, one thread to handle user input-output. That's when you're working with a GUI program, which you are if you're going to create that with Java. So you're going to have an interface. You don't have to, but it's just we're so used to working better with interfaces and GUIs than we are in just straight command language. So something for you just to look at. And again, any questions so far? It's pretty much the end of our session here. So any questions? I did record this. You can view it again. If you know a classmate who didn't attend, remind them it's there. I will put these slides in the classroom so you have access to these links and information. Again, do the practice exercises. It will just help you. Bring your questions to the discussion forum. You don't have to wait till Wednesday. You can put them in the discussion forum right now so we all can start answering it. Okay, good enough. So hopefully you are all clear. We got a good process going, and we're going to be looking at processes. And again, if you have any questions, don't hesitate to reach out to me and your classmates. You can start now. And again, yes. And again, take those key topics and start, you know, if you do the chapters every week, then you don't have so much during the midterm or for the final. You already have it done. So start taking your notes as you read. Identify those key topics. Look at those practice exercises as you read the chapter, and then answer the exercises. And then we will meet again on Wednesday. Thank you so much and have a great day.